This video we will talk about virtual function. So the virtual function is using for throughout the inheritance hierarchy. The reason is even we have the inheritance relationship, but all the member function with the same name in the base class or derived class, honestly, they don't have relationship. For example, we have the print function in the commission employee class, the parent class. We also have the print function in the base class commission employee, the child class. Even the both function they call print, but they don't have relationship. They are just individually reside in each class. Like earlier we demo. Even you have your parent class have the print. So then when we create the child class object, we also have their own print. So even you have inheritance relationship, but they are just two individual functions. However, if this print function, they do have their own common behavior. For example, print function in the child class will print the child class object information. So the print function in the parent class will print the parent class object information. They both have the same functionality for different object type. So throughout the inheritance relationship in C++, we need to make the connection for these two print functions. So those functions we call the virtual function. Virtual function basically is, we say, the common member function throughout the inheritance relationship. We need to make the connection for them. So in order to make the connection, actually we need to define the virtual function in the parent class. To enable this behavior, so all the virtual function you need to define in the base class. After you define in the base class about the virtual function, throughout the inheritance hierarchy, in the child class, in any child class, they can override the virtual function. So the overridden virtual function in the derived class, they has the same signature and the return type. That's mean if we try to define any function is virtual function, right, in the base class. So in the child class, you can try to overwrite your implementation for those virtual functions. But you should be careful is you will never change their signature, that means the parameter, and their return type. So that's why throughout the inheritance hierarchy, the virtual function, they will know which one they will be invoked during the program runtime. So this one actually is we call the dynamic binding. But one thing is, let me show you the example first. So then we will tell you what means the dynamic binding. So now the virtual function example, we were using the directory for the example 4 under our module 12 example. So you can download all the file for the base class header file and source file, and the child class header file and the source file, and the driver program from our example folder under the demo file in module 12. So then you will see here how we will define the virtual function. So that's why you see here is our commission employee class. You have your private data attribute, so all the member function. But here we will see here, because one thing is we will have our earning Because earning, how we calculate in the commission employee, we have our own formula. But after the derived class inherited from the parent class, they may have their own formula how to calculate their earning. So the same thing throughout the inheritance hierarchy. Different objects, how they print the information will be different. So for any function, you feel like through the inheritance relationship, all the child class, they may need to define or re-implement according to their necessary need. So those kind of common function we should define as virtual. So after you define this function header, add virtual at the front in the base class. So throughout the inheritance hierarchy, so these two functions, they can be override through the child class. But throughout the inheritance relationship, we have later will show you they have a virtual table to see how they will override from the child class, derived class. So earlier you see how to run the program, but here is the UML diagram. So you will see the change from the base class. We just add the virtual keyword to our earning and the print. So after you did that, right? So actually, after you do the inheritance relationship, once you inherit it, then actually the virtual keyword is also in the earning and the print function in the child class. So actually the virtual keyword in the child class, actually they are not necessary. They can be optional. The reason is because we already declare and define these two functions in the parent class to be virtual. So that's why in your child class, you type the virtual keyword or not, it doesn't match it. So let me show you here. That's earlier we show you that's the parent class header file. We add these two virtual functions. So when you do the implementation, actually nothing will change. On your implementation, nothing will change. So you will see the virtual keyword, like the static keyword, you only need to declare that's in the header file. Once you have the header file, this member function have virtual keyword, right? So in your CPP file, you will see here that's the parent class CPP file. Actually, we have nothing changed. We just implement all the constructor function and the member function. So earlier we have the virtual keyword in the earnings and the print. You will see they are still the same. You don't have to add the virtual keyword in the source file when you implement the function. You only need to have the virtual keyword in the class declaration in the .h file. So that's why here in the PowerPoint file, I didn't really show you the CPP because they are the same. So then after you have this base class header file, define the virtual. So then in the child class header, right, we still inheritance publicly. So then afterward, this one you see, we still have the earning and the print function header here. But the virtual actually you don't need to put either here. However, if you want, I will recommend you still put the virtual because this one just kind of like remind you in the child class, you still know these two functions actually came from the parent class virtual function. So the most important thing is once you have virtual keyword here, your header, that means your return type and signature cannot change. So the same thing you will see here. I only show you in the PowerPoint file at header because after you add virtual in your CPP commission base plus commission employee CPP file, nothing will change. Okay, so that's commission employee CPP file. So you will see even you have the virtual for print and earning, So then they are the same as before. So what will really happen? So what will really happen? So in the example for the CPP file, we will just do the same thing as example 1. We have the parent class pointer, parent class object, parent child class pointer, child class object. So when we try to invoke the print function just through the parent class object or child class object, they will just invoke correctly, right? However, remember we say if we have my parent class pointer refer to the child class object, that's polymorphism, we can do that, right? So in the example 1, when we try to do that, if our two print function, they have no relationship. So even we have the parent class pointer refer to the child class object, when we're using the parent class pointer to call the print function, they still only call the print function using the definition in the parent class object. However, now, if we make our print function become a virtual function, then when you're using the parent class pointer refer to the child class object, then the virtual function, they will do one thing is we call the dynamic binding. So even you have the parent class pointer refer to the child class object. So when we call the print function, right, when we call the print function, they will come to parent class pointer to see the definition first. So when they find the print function, actually they see, oh, print function is a virtual function. So once they see the virtual, so throughout from here, you have parent class pointer, but because they see the virtual, since they see the virtual, so then they will try to go to see the runtime, which object they are really invoked from. So then they will seek out if they have the print function implement in the dynamic, the current object they are referred to. So that's why that's now if we make our print function become virtual, so then the print function will be invoked through the child class object. So that's why you see here in the example for CPP file, we still create the parent class object, child class object, parent class pointer, child class pointer. So when we invoke the print function through the object or through the pointer, they will just invoke correctly. But now when we make our parent class pointer to refer to the child class object, so now the new print function, because they have the relationship now, because they are virtual function, so that's why they will do the dynamic binding to really invoke the child class object. So that's why you see that's the last result we show. So then you will see this print function even we invoke through the parent class pointer, because when they go to the parent class definition, see the print function is a virtual function. So then they will throughout the dynamic binding to find the real object they refer to. So this print function will be invoked from the child class definition. So that's why virtual function is very important throughout the inheritance hierarchy. Because why we want to have inheritance relationship? Because you see here, we have so many different employee. We have commission employee. We have commission base plus commission employee. So also I can add the hourly employee. I can add the base salary employee. So then they have so many different kind of employee. So then in the future, maybe I should add an employee class as a base class. So sometimes when I have all the employee, I want to have the collection for all my employee object. I definitely don't want to create all different kind of array. I want to have a base object array to hold that. So with the virtual function, they will